What is this? Sine of 101x times sine of x to the 99th power? 101x and 99th power. Oh man, what do we even do? I have seen a lot of crazy mathematical questions in my life, but this one is insane. This is one of the craziest. 101x, raising it to power of 99. Why can't they give us something easier, like just integrating sine of x times sine of x, or something of the form? But we have sine of 101x times sine of x, and you're raising it to 99th power. Okay, let me stop emphasizing the seemingly difficult nature of this question, but actually get to work. But how do we even start this? You have 99 and 101. Is there a way to make them similar or make them even out somehow? Well, both of them are fairly large, and it's not very obvious how we can start working with 99's power and coefficient of 101. But we see that they are very close to each other. In fact, the average is 100. So if we can maybe change them to, instead of 101, maybe change it to 100. Instead of 99, maybe change that to 100 somehow. Maybe it's going to be easier, because having the same numbers show up within the integration is usually a good sign. That usually leads us toward the path to victory, and victory being evaluating this integral. Okay, so 101 and 99 is conflicting. They are way too far apart. Let's try to maybe neutralize them by forcing 100 to come about. And one way of trying it out is to split sine of 101x into sine of 100x plus 1x. And using trig identity, you know this thing is same thing as sine of 100x times cosine of x plus cosine of 100x times sine of x. So let me write that down. So we, instead of sine of 101x, we're now going to write sine of 100x cosine of x, and let me leave a space for now, plus cosine of 100x times sine of x. And to this thing, you're multiplying by sine of x to the 99th power. You're distributing. So sine of x to the 99th power is going to go in right here, sine of x to the 99th power. And here you already have one sine of x, so you're going to get sine of x to the 100th power. Okay, what do we do now? It looks like cosine of 100x times sine of x to the 100 may be possible to integrate. That seems easier, but we have this craziness residing to the left. Sine of 100x times cosine of x times sine of x to the 99th power. How do you integrate this? Well, it's hard to look at each of them separately, but why don't we try to make connection between these two terms? Let's try to make a connection. And you may realize that these two look very, very, very similar to each other. And how are they very similar? Well, first of all, you have two terms, which is nice. It's nice that we just have two terms to work with instead of 20 terms. Okay, but that's not as major as other things that show up within this integrand. You have sine of x to the 100th power, and realize you have cosine of x times sine of x to the 99th power, and these seem to be related, very closely related by the process of differentiation. And what do I mean by that? When you differentiate sine of x to the 100th power, you get 100 times sine of x raised to now 99th power, and by chain rule, you gotta differentiate what's inside and multiply by that. So differentiating sine of x gets you extra cosine of x. Realize how when you differentiate this expression, the sine of x expression, you're getting 100 times cosine of x times sine of x to the 99th power. Okay, so that's very close relationship. Do we have any other differentiation relationship? And it turns out we do. We can differentiate sine of x to get cosine of 100x or something very similar to it. So when you differentiate sine of 100x, we know you get cosine of 100x, and you know you gotta use chain rule, multiply by derivative of 100. So you gotta multiply by 100. You gotta multiply by derivative of 100x. So you gotta multiply by 100 by the chain rule. So realize when you differentiate sine of 100x, you get 100 times cosine of 100x. And realize going backwards doesn't really work, because when you differentiate cosine of 100x, you're going to get negative sine of 100x times 100, and we don't have any negative sign, so that's not going to work out the way we may intend it to. So we have this very compact differentiation relationship between the terms inside the integral, and what can we do with them? Well, it looks like we may be able to apply product rule or the reverse product rule even, because product rule tells you when you differentiate a product f of x times g of x, you get f of x times g prime of x plus g of x times f prime of x. And it seems like we have something similar to it, because you have a function, you have a derivative of that function on the other side, and you have another function and derivative of that function on the other side. So we have this very compact relationship, and it looks like it fits this product rule right in. So in our case, sine of 100x can be f of x, and 100 times cosine of 100x is going to be f prime of x, and you have sine of x to the 100x being our g of x, and you have 100 times cosine of x times sine of x to the 99th power being our g prime of x. So we basically have f of x g prime of x plus f prime of x g of x dx. Okay, so this is just going backwards. So what do you have to differentiate to get the thing inside? So what happens when you integrate it? Well, you're just going to go backwards. So you're going to get f of x times g of x. So the solution to this is going to be f of x times g of x, or sine of 100x, that was f of x, times g of x, which was sine of x to the 100th power, times sine of x to the 100th power. But the thing is, we gotta get rid of this 100 multiple somehow, because you're multiplying by 100 to both sides of the equation. You can get rid of 100 by dividing by 100 to this. So you can divide by 100, and we have the solution to our question. So let me write it down. So the solution to this question, integral of sine of 101x times sine of x to the 99th power, is 1 over 100 times sine of 100x times sine of x raised to 100th power plus constant of integration.